Well, first off, thank you very much for giving me part of your afternoon. I appreciate it. For those who I haven't met outside of John and Kurt, my name is Brennan Doherty. I work for MyFab. My role within the company is really to travel around the country, meeting with owners, engineers, and design build contractors, educating them on siphonic drainage. I myself am published. I was able to help get siphonic drainage added to ASPE's newest design handbook. So it's out there. Everybody is aware of it. Siphonic is both IPC as well as UPC approved. So in pretty much any territory you're going into, it just needs to be stamped off by a licensed plumbing engineer. The goal of today's conversation is to make sure you're comfortable and competent talking about siphonic drainage around a round table, whether that's with somebody on the team, an engineer, an owner. We just want to make sure you understand what's going on during that conversation. We will, at the end, after we get done with our education portion, go over how to submit a project. So if you guys have something you're working on, you can go ahead and have our team let you know what a siphonic system would look like. But without further ado, let's jump into it, okay? Okay, as far as where to think about this so you can understand during this presentation, where should I be looking for a fit? I'll send you a project list after this, but it's really all over at this point. I mean, we have siphonic drainage installed in just about every kind of situation you can think of. As far as partners go, Amazon's obviously a big name. Walmart's going to be one of the biggest proponents for it. There's over 1,000 plus Walmarts with siphonic drainage installed on it. Costco being the second lead there. And then again, just a splattering of other companies that also have used it within their designs. What is siphonic drainage? In layman's terms, when you were stealing gas from dad's car back in the day, we got that hose primed with fuel. We created a siphon effect. That's exactly what we're doing here, except at the roof level. The first major difference you're going to notice is a siphonic system allows us to use roughly half the diameter storm pipe. So where we're running an 8-inch gravity, it's going to be a 4-inch siphonic. Why is that happening though? A traditional gravity drain requires 2/3 air mixing with 1/3 water in order to efficiently transport through that system. With a siphonic drain, we're actually going to introduce a baffle plate over the top, which is going to eliminate that air from entering the pipework. Because we don't have that air in there, that's how we're getting that half diameter. The second big advantage of a siphonic system is it runs dead level flat. There's no installed pitch or slope to it whatsoever. What's happening here, similar to a fire protection system, a siphonic system is hydraulically balanced. So the routing is going to be given into a program, and it will define what those diameters need to be to create an efficient siphonic system. The high school thought to it, vertical is energy gain. The natural height of the building is generating that negative energy, creating that pull from the roof. And then our horizontal is going to be our energy loss, as well as any of our fittings changing a direction. Getting kind of a visual, the other big advantage is because we have that pipe running dead level flat, there's no installed slope, we're able to collect all of those drains at that higher level, routing it to one vertical. Versus traditional gravity, as we can see here on the left, and we're very aware of, we have to have multiple risers throughout that building because we can only go so far before getting a livable space, at which point I need a vertical riser there and we can collect it below grade. Number one, we've already covered, again, large diameter pipe needs to account for that air. Number two, just talked about right now, with that pitch, we need to have additional verticals. We need to have additional pipework, sleeving. But number three also builds on that concept. With traditional gravity being dictated by pitch, that generally dictates where we have those civil connections because I can only run the pipe so far and I need to have civil come meet me. Finally, last, gravity drains clog. It's inevitable, and I'm sure everybody's been to enough projects to know they've seen something like this. Being a millennial, I got TikToks just to keep it topical as well. To be very clear though, this is preventable. Doing your regular maintenance, getting up there, can't avoid this, but this is one of the things that goes by the wayside first. What about siphonic drains? In the video I'm about to share with you right now, What we did is we took 3 giant garbage cans full of wet pine needles and leaves. We threw them in here. We're about to simulate a flash storm. What I want you to notice first is there's no debris guard over that siphonic drain. What happens with traditional gravity is what we've seen in those previous videos. The leaf and debris get pulled towards the drain, meaning that water level has to rise in order to overcome that leaf and debris to exit the system. So we start seeing our wet spots, our leaks, and ultimately our roof drain failures. With a siphonic system, what ends up happening is the leaf and debris get pulled towards the drain, but that siphonic action pulls the leaf and debris completely through the drain and out of the system. This siphonic action starts occurring at only about a 1/4 inch to a 1/2 inch of ponding on the roof, so that drain does not need to be fully submerged. Once that water level has gone back down, there's no more leaf or debris left on that roof. Earlier, there are about 1,000 plus Walmarts all across the US with this siphonic system installed. So we know this is tried and true. Above and beyond that, siphonic drainage has been around in Europe since the 1980s. If you read any of their scientific white page papers, it's widely known that a siphonic system can self-scour. So this is nothing special, nothing secret. As I mentioned too, just a minute ago, biggest thing I hear traveling across the country that people hear come to me, well, I was always under the impression the drain needs to be submerged to get the siphonic. I'm gonna need to talk to structural and make sure we can support that weight. Couldn't be further from the truth. Only a 1/4 inch to about a 1/2 inch before that ponding starts having that siphonic effect. In reality, a siphonic drain is about 3 to 4 times more efficient than your gravity. We can go ahead and look at our charts too and see here for a 4-inch drain at 2 inches of ponding, it's 90 GPM versus about 350. So it's pulling that water off the roof. Even though it's using smaller size pipe diameter, the velocity it's going through is at a much higher pace. What's happening is a siphonic system follows 4 basic flow patterns. Stage 1, we have a light rainfall. It's going to act as a traditional gravity system, no different there. As that rain starts to intensify and pick up, it's going to enter stage 2, which is that wave or plug flow, where anything on that roof is going to get pulled completely through that system. Then stage 3, it's getting there. Stage 4, we have complete submersion of the drain. That pipe is 100% full of water at that point. Okay, just using some visuals and putting together everything we've talked about. Benefits of siphonic drainage, a lot less pipe, a lot less labor, right? System on the left, designed using gravity. System on the right, designed using siphonic drainage. As we can see, there are savings for both that plumbing contractor as well as the civil. For that plumbing contractor side though, the elimination of these vertical downspouts, not only material, but also labor, the elimination of this internal excavation. Then on the outside, the elimination of these manholes, which are hard cost, plus the pipe work and the excavation for it. But regardless of what side of the coin you're on, if we don't have all these drops and we can route everything to one vertical, and this is not a complex system by any means, we have the ability to cut down on the coordination, the potential conflicts, the time on that job. And from that construction side as well, I don't have to go to every single one of these verticals and put in my test plug and test that system. I can go to one vertical, put in one plug and inspect the entire system, saving my labor on that side as well. High rises, anything tall, again, 5 stories, 4 stories or more, we can save on eliminating verticals as well as sleeving, as well as coordination. We can give that owner back real estate on every single floor, which is going to make their building more valuable as well. And then warehouses, I mean, data centers, anything big is a no-brainer in my opinion on it. Reason being what we see here, traditional warehouse, we still have our gutter downspouts. If you're able to gutter downspout and go right to grade, you can go to that pavement. Cheapest option, do that every time. However, a lot of situations, even though we have our gutter setups, we're still haven't had that civil come to the building, which is still a piping cost. Might not be on your scope, but if you're part of that overall team, this is going to add to your cost savings. Idea being, right, you don't have to shoot the moon. You can go ahead and cut down, what, 6 different verticals right there and some civils, or you can go ahead and connect 8. Go ahead. We have a project we're working on right now where we have 16 we're connecting. We worked with Mercedes-Benz where we ran it 1,200 feet dead level flat. So, I mean, it's really up to you, but the concept being, instead of routing that civil all the way down, route it all to one end of the building. Same thing. If you don't want to go to that side of the building or you have an obstruction, you can route everything on that side all the way to the south side and get to that design implementation. Benefits, though, again, we've gone over. Smaller pipe, smaller diameter fittings, coupling, hanger, insulation, bracing, sleeving, pipes running flat, easier coordination. Storm drainage right now is large diameter and it's sloping. We're fighting for room to make it work. It runs flat, half diameter, same as our HVAC, fire protection, electrical. So it's got its own dedicated plane. We're going to have less overall clashes and, again, keep that construction project moving. Less ponding, anti-clog, and less pipe work means less labor. Anybody can put that together. Codes behind siphonic drainage, what we have to be aware of. There's really only 2 basic ones. It's pretty easy. ASME A112.6.9 is the performance standard for the drain, making sure we don't just put a piece of metal up on there. It does have to meet certain standards. And then number 2 is ASPE 45, and that's really the holy grail for siphonic drainage. Siphonic drainage is, as I mentioned at the beginning, both IPC as well as UPC approved, and they're both asking for approval for the 2 standards I just mentioned. Engineered system, it does have to be stamped off. One thing I do want to point out, I think it's worth noting and at least bringing up, 2012, ASPE Research Foundation did a study where they took all of the US drain manufacturers' gravity roof drains and did a test. So we don't know whose drain is whose, but we do know all of the data is apples to apples. I'm going to take this from that study, so I want to let you know where it came from. But if you guys are in a UPC territory, we size using flow charts. We have a 10,000 square foot roof with a 3-inch rainfall rate. It dictates we need a 6-inch roof drain to make it work. Okay, if we're in an IPC territory, and this is generally the IPC map, anything outside of it's going to be UPC, right? They size based off of flow rates or GPM through the roof drain. That's the same thing as siphonic. And really, the math behind it is this formula, right? GPM is figuring out our design rainfall rate as well as our area and just a couple factors. If we use that same metric we use to size in UPC, 10,000 3-inch rainfall rate, it dictates we need 314 gallons per minute to handle the requirements, okay? If we're using that 6-inch drain from the study, to be UPC compliant, we only need 1 6-inch drain. Simple as that. We've met code, just 1 6-inch drain. To be IPC compliant, we do need to take GPM into account. So using this, we would see at 2 3 inches, I'm really not meeting that. So I actually need 2 of this 6-inch drain on my roof in order to meet that code requirements. Again, both IPC and UPC are both approved. It just depends on where you're going, but I do want to point that out. For siphonic, we actually only need 1 3-inch drain. Our 3-inch drain is able to handle up to about 400 gallons per minute. So, 122 by 122 maxing out. But that is really no issue. Other bigger thing I do want to point out here, if you look at the chart, right? This is for a gravity roof drain. As we increase our ponding, going from 5-inch of ponding to 6, we actually have a drop in GPM flow, contrary to popular logic, right? Any idea why that might be happening? Think to yourself for a minute. It goes back to the first point of our conversation today. and that is gravity drainage requires air mixing with water in order to efficiently transport through that system. What ends up happening with the gravity drain is as that water level rises, the weir collapses in on itself. Or think about when you have a bathtub and you got that tornado collapse in itself, and there's no longer air getting to that drain. So at a point, we know gravity is going to start becoming inefficient. With siphonic drainage, as we start getting that rainfall, it's going to start becoming more efficient. Okay. Things we do want to be aware of for a siphonic system when we're installing it, differences between gravity. Or sorry, I guess a few example projects I have in here. Number one, just a really cool one down in Mexico City. They actually, on top of a Costco, ended up building soccer fields, basketball courts, some green path, liveaways. We have siphonic drains within here, and basically it's got a bunch of trenches connected to a sump pit. Within the sump pit's got a siphonic drain. Just a different way of looking at it. Again, a couple little pictures. DBIA project of the year over in San Francisco. It's a federal project, but the new resources, it's got basically all of their state departments housed within there, but siphonic drainage was used as part of that design. Fifth and Broadway, if anybody's been to Nashville within the last 2 years, just 2 giant towers, as well as a bunch of cool food courts and a band concert area in there as well. And then Amazon, we work with as well, giving you kind of an idea of what one of those sumps look like, parking over it so you can go ahead and be drivable. Cool thing about this one was they used rainwater collection. So they have a couplings under it. And basically it's all these little plastic units that they go ahead and tie together, pour the concrete over top, and it makes its own little tomb. And then stadiums too, just a number of different things, but rules for siphonic drainage. Some of the questions we're going to answer in this next part, and if you have any that we don't hit, please feel free to speak up, okay? Okay. As far as the drains go, there's really not too many options. Left is what Walmart uses. It's your normal typical membrane style. Membrane's going to go in there and clamp down. Left is what Costco uses on their design, and it's a stainless steel spun design, and they basically A-frame as well, and they just have a little trench on the side with a parapet wall, but they throw those in there. We have smaller ones as well that need about an 8-inch wide gutter or a 10-inch wide gutter, but those options, yeah, you can see it right there, are available as well. Parking sumps we talked about. Ballast, any paver style, you can also do too. Best fits, we'll go over that later. Rule number 1, you need to have an overflow drain by code. You can't get away with it just because the primary is that much more efficient. It does not have to be siphonic just because your primary is, and vice versa. If you want your overflow to be siphonic, same design parameters and benefits. We use a 2-inch water dam standard. Unless you go over about 300 gallons per minute, so those large warehouses, at that point, we will advise, as the chart dictates, with the gravity drain, you're going to be doing that well before that 300 anyway. Rule number 1B, we do have a minimum design requirement for siphonic drains. It needs to have a minimum design of 23 gallons per minute. Reason being, it just needs to generate that to be able to have that self-scouring effect go through the smallest diameter, which is 1.5 inches. It just basically means we can't have any area drains or planar drains be connected. They just would never receive enough rainfall rate to get to that flow. That 23 gallon per minute does depend on rainfall rate. It's used when we're sizing in, again, GPM situations. But as you can see here, if you're designing in Seattle versus like in Austin, Texas, require 1,100 square feet versus about 600. I generally say shoot for about 1,500 square feet just because you know you've covered yourself on anything. But as you can see here with our drains, you can get pretty big on what you can cover if you want to push it to its limits. Rule number 2, if you have separate roof levels, you need to have separate siphonic systems. And the reason is if they're connected, you might have the chance of air ingress, just because you might have rain up this upper roof and no rain at the lower roof. not the end of the world. You have separate systems. We'll break them back to gravity, at which point we can tie them together, and we'll cover in the next few slides how we're going to do that. Rule number 3, for a siphonic system, we're always going to break back to gravity flow at point of discharge. And it's following 2 simple rules in order to accomplish this. Number 1, we need to increase our pipe diameter back to that gravity size flow following our IPC or UPC flow charts. And number 2, we need to reintroduce atmosphere. And there are a number of ways to accomplish this. The most cost effective, whatever civil is feeding that manhole, have that manhole be slotted instead of solid. That will require coordination with civils. So most of the time, people don't want to worry about doing that. So what they end up doing is putting an area drain 5 feet outside of the building. That way, we're breaking back to gravity sized pipe, civils getting gravity as they have every day of their life, and there's no coordination required. But if you did want to coordinate with civils, you have the ability to take that siphonic pipe out even further. Siphonic runs that level flat, not only in the ceiling, but also in the groundwork. So limitation, again, is going to be height of that building. If we had multiple siphonic systems that we wanted to break into the same discharge, or sorry, let me step back, I apologize. Third option we have is to break in the vertical. To do that, all we need is a vent to atmosphere equal diameter to our siphonic discharge. So 3-inch siphonic, 3-inch vent. That could go back to the roof. That could go ahead and go out a sidewall and either be a downspout nozzle, could go out a sidewall and be an HVAC grate. It could go to a nearby floor and be an oversized area drain. It just needs to vent to atmosphere. If we have multiple siphonic systems, we're tying into that same pipe. We only need one vent. You can vent it accordingly. If you were tying the siphonic systems together in the horizontal, you can tie them all into that same collector pipe, and you'd only need one area drain in that situation. For the overflow, the downspout nozzle is going to act as our atmospheric brake, so we do not need any additional vent pipe work. We are going to recommend that you brake to gravity before you go out of that wall, just so you give time for that water to mix with the atmosphere so it can slow down before going out the building. These are examples of how to slow it down more, just add more fittings, but this is not required by the standard by any means. You can still go out the wall all the same. Rule number 4, there are additional bracing requirements. They're very easy to suffice. 3 and 4, we're doing for gravity already anyway, so no different there. Just supporting that pipe in the horizontal with traditionally our clevis hangers and support, as well as bracing or bracketing it in the wall or column on the vertical. Number 1 is new. We're going to add bracing 1 foot away, 1 to 2 feet away from every change of direction. So that's 2 points for a 90, 3 points for a Y. That can be as easily sufficed as using hold right 117. So just a casting that goes around the bracing. We found that to be the most cost effective talking to people. Rule number 2, we do need to have sway bracing every 30 feet in the horizontal. And that can be as easily sufficed as just adding some stainless steel aircraft hanger cable every 30 feet on those supports. Okay, again, the supports are already there. Those are just recommendations. The purpose of the standard is to make sure that pipe is not moving longitudinally or laterally. We've seen people use unistrut, but as long as you're making sure it's braced, that's what the purpose is here. As far as install devices go, it's going to go on the roof the same as traditional gravity roof drain. Really no different install there. If you're using a bearing pan, that's great. If you're using an underdeck clamp, that'll work. Extensions, the bearing pan's benefit is that it can be used actually 2 ways, 3 ways really. You can sit it in there. It's already got the holes in there, so you don't need to burn anything out. But you can also flip it and invert it and go ahead and prefab everything below ground. Do your stub outs, and then go on the roof there and get to everything below grade. Just a nice little example here, your overflow and your primary. As far as fittings go, really nothing crazy. For 90s, we cannot use any knuckle bend 90s. It's just too hard of a transition. So long or short sweep. Cleanouts are not required. That's something that is very different. We 100% don't want to use this end style. just create a potential air pocket. We can use this spool type, and we actually recommend using that anytime you're going underground. Reason being, just for that inspection plug. Again, not for rotting. That system's going to clean itself anytime it gets a substantial rain. Other benefit to this, just in your design as well as when you're quoting and estimating, if we don't have to have these at every change of direction, we can run that pipe a lot tighter and cleaner. We don't have to make sure it's in an accessible area. And again, it's one less area that we have to inspect. Other little random comments. As far as pipe material goes, no different. It's what you're using every day. It's nothing special. Eccentric and concentric reducers are both approved. It only requires standard duty coupling, so you only need to use the 2 bands. 4 bands are more than acceptable. And you guys obviously are using our quick hubs right now. Those meet code as well. I'm going to hit this one last, but other one that I do want to point out, in the vertical, you are only allowed to restrict pipe in the direction of flow. So we're going to go from a 4-inch down to a 3-inch. All the standard allows for. The logic is that smaller diameter pipe allows that system to fill up quicker so we can get to that siphonic mode faster. But 3, most importantly, any system out there should have a calculation report with it. So we know there's no chance of cavitation. You are covered. And last bit, you are required to communicate any changes. Anything over about a foot, it's 8 inches, does need to be communicated back. So one of the questions I'm always asked is, why isn't it bigger? Why don't we see this on more projects? Number one, because technology has finally caught up. We finally have the ability to do it quite easily. But number 2 is communication. It's not something that you can just be in the field and offset and hope you're the first one there. The reality is, we are using this on these highly engineered projects where we're BIM modeling already, and we already know where that pipe is going in before we put it in. We're just making life easier for ourselves. Step even further than that. The other major difference we have, which we'll get into now, the what's MyFab doing to make life easy. We have 2 guys in Chicago that are here full time to help design, balance, and implement these. So any changes, we have a pretty streamlined process, which is what we'll go over here in the last little bit. As far as kind of an overall comparison, now that we've got the views and all these little pockets, difference from gravity versus siphonic. Siphonic installs with no slope, reduces in the vertical. We don't need the cleanouts. We have to have an air brake. The additional pipe bracing we covered, and the changes have to be communicated as we just covered there at length. What's the same though? No different on the roof. You're putting a roof drain on the roof. Pipe material is going to be the same, no different there. The support as far as just getting it up on that system is exactly the same as you're doing right now. And the inspection's exactly the same. We don't need any performance tests. It's just making sure you're doing a fittings test. Okay, how to submit a design, what that process looks like. One second here. Number one, you need to lay out the system, whether it's on blueprints, whether it's on a Revit model, which is our preferred method. It could be on a cocktail napkin for all we care. We just need to be able to understand the routing that pipework's taking, both the vertical and the horizontal lengths, so we can input it. When you are doing your drawings, please note, the pipes do need to connect on the horizontal. We can't have it drop directly in on the vertical. It just wouldn't be able to create that siphonic pull. That tailpipe is where we're creating that action, really generating across the roof. So just please note that if you are looking at projects or throwing a design together. Option 1, best Revit model, and I'm just going to cruise through these real quick. If you have a roof plan though, just make sure you send the elevations with it. We also need to know what square footage it is, and it'll ask you, rainfall rate and all that good stuff. Go ahead and blue beam it up if you want to. My team can do that all the same though. Just going through it again, cocktail napkin. To submit something, just go to myfab.com. Right at the top here, we have a button. Takes you right to this page. It asks the bare minimum. I have not asked for anything we don't possibly need. What happens is my team takes that data and we throw it into our design program and we balance it. And what I mean by balance it is we try and get this pass. So what they're doing is they're trying to figure out what diameter each of these pipe lengths need to be to have the most efficient siphonic system. So when it does get a rain event, all of those pipe work, all of those pipes are filling up at the exact same rate. So all those drains are entering siphonic mode at the same instance. Benefit with us versus anybody else. Once you get that green pass, we have a letter from a third party showing you are 100% compliant with the ASPE 45 standard. Part 2 is that listing showing the performance standard. We have our ATMA listing for that. So as long as we have a passing design, it's 100% compliant with both IPC as well as UPC. Again, our program is going to spit out calculation reports. That's what's going to show compliance, as well as a bill of materials. So you can go ahead and cost out what that project would be real quick on a budget. The bracing is not included on that bill of material just because we don't know what's going to be used or where it is going to be placed. From that model, there's no button we can press. So to get anything usable, number one, my team makes a Revit model. So it's there free for use, but more importantly, they make the install blueprints. So it tells you on there all the fittings needed, the diameter, the lengths of the pipe, as well as the GPM of every pipe, or every drain on there. So no extra work needed on your part. It's all provided as part of the cost of that drain. Back of that as well, we also have a blueprint guideline. It's everything we've covered here at the last part of our class. But we send that out standard with every single ISO, just in case for whatever reason, you send the plans out and you didn't get a chance to discuss it with somebody, you're already covered on your end. Everything was mentioned there. They can't go ahead and play dumb. Other than that, really the end. We have over the world 8,000 siphonic projects, no issues, no roof drain collapses. And if you need any help, I am definitely here to answer questions. But while I'm in the room today, what can I answer for you guys?
I have a question. What's you guys know like a good breaking point, like between a traditional gravity system and a siphonic? Like, is it 10,000 square foot building, 50,000 square foot building? I was gonna get with our senior estimator Nick here, and maybe we could send something and just kind of work on that too, unless you got an idea as far as where the cost savings at and the size of the building.
So for me personally, I think it takes about connecting 3 drains together to make cost sense, just because you're killing 2 verticals at that point in theory. That to me is where it starts seeing savings, but
what's usually the cost difference between, say, 3-inch standard roof drain, a 3-inch drain?
I mean, I think a traditional gravity roof drain's probably like what, $400, something like that. Siphonic, your cost contractor, probably going to be around $1,300.
There are accounting types that we work for that's what they look at, and so then it's like, how do we properly educate them on all the parts and pieces when we really don't even get the time to be in front of them? So they would ask how much for the roof drains or whatever, you give them that cost, and then they throw up a red flag, and then you'd have to go through that whole process of educating them if they'll even listen to you.
So it is going to be a higher cost drain. However, if you're looking at the cost of drain, you're going to get lost on it. It's the less pipe, it's the less labor, it's less sleeve, penetration, all those other ancillary things add to that overall cost. It's not just that one right there. And it's, again, the reason why you have these big companies using it on their designs.
I mean, it works. Like, Brendan, I was at Hometown Plumbing and Heating when they did the Iowa City Public Works, and I was actually the one that did most of the communication with Hydromax at that point, right?
Correct.
Do you guys still label it as Hydromax? MyFab? There's just MyFab now.
No, it is Hydromax. That's who we partner with over in Europe.
Okay.
It's a software.
I got you. Okay. It worked out.
What's the turnaround time when we submit something online to get a drawing or a material list? Or I'm thinking you could maybe take off from those drawings.
Yeah, as again, the vertical is usually the biggest thing we're missing. As long as you're gonna have that, it gives you a little checklist on there to make sure you have everything. But as long as you provide it, we can take it off. We're about a 3 to 5 day turnaround on anything new. But if it's a project we have live with you, my guys know that that gets treatment. So anything live is getting a 24-hour turnaround. Worst case, and that's usually us just waiting for information back. My team is extremely good at communication. They're the best part of the business, if I'm being honest.
So with it, so if it is a situation where you guys are designing it and doing all the layout and everything, or after we lay it out, would you guys share your material list and everything at that point from an estimation standpoint?
Yeah, we'll give you everything. I'll give you access to the program. If you want to have somebody in the office too that knows how to balance, we're not secretive of it.
Yeah, we might, here in the next week or something, try to maybe do that federal building or this Cottonwood or something, just so we can get a little more familiar with it, and then we can run it through our estimating program too and do comparisons and see what, yeah.
We're cruising. Whenever you guys are ready for us, throw it over and we're ready for you. All right.
So when we upload, and I think you went over this, architectural drawings.
Here, let's just. Right here, and then it'll literally right here go, make sure your roof drains are on there, make sure you got the square foot for it. We have our elevations. What's that pipe routing look like? And then just making sure we know where that's civil. If you don't communicate where you want to break it, they're generally going to run it 5 feet outside of the building, and that's where they're going to kill the siphonic. But
So if we've already got it laid out, we don't use Revit, but we could give them an ISO view overall with lengths on it.
yeah, you could do it on a cocktail napkin for all we care. We just need to be able to input it into our balancing program.
Take that ISO view of all the storm and put dimensions on it, and then give a footage, and I'm gonna tell you what side of it.
Yeah, and Brent, can I see if I can share my screen?
Please let me know if you can't.
What?
It's supposed to be seen.
So this is the roof plan, which we do show roof drains. I mean, so even if they do show how it's pitched to the roof or pitched to the drains, do you guys need us to put the square footage on there?
I would prefer it just because there's really no question then.
Gotcha, okay.
It's just cleaner on everybody.
So we could just mark this up in blue beam, like that where my cursor is, that goes to that roof drain. This area goes to that roof drain.
You got it. And then just second thing, make sure if it's separate roof levels, they're using separate verticals, okay? Because it looks like that northeast corner is on a separate level
Yeah,
now.
this is a separate roof level. This is a different level.
All the rest.
All the rest
Oh,
of,
that's-
well, except for this is like a stair tower, which they eliminated those now.
Stair tower, just drain to that lower roof and include in that GPM for that drain right there.
Yep. I think we got a decent grasp on it, Brendan, and appreciate your time today, and yeah, hopefully you'll be seeing some more stuff from us.
Look forward to it, and thank you for the opportunity. Good seeing you guys again.
Yeah, thanks, Brendan.
Cheers.